student, welcome to the another video of our course, that is Discrete Mathematics, and in this video we are going to study about the type of relations, and we are mainly going to see the complement and inverse of relation today. So if you are new to this channel and if you haven't watched my previous video where I have discussed about the relations, you can watch my previous video from my playlist. And if you are new to this channel, please do subscribe and don't forget to press the bell icon so that you can get the latest notification whenever I upload a new video. So without wasting much of time, let's start our tutorial. Suppose, before starting the types of relations, or here in this video we are going to learn the two basic type of relation, that is complement of relation and inverse of relation. So before starting the complement and inverse of relation, first we need to know about the universal relation. The relation R is said to be a universal relation if which contain all the elements of cross product. So suppose we have two sets, set A and set B. Set A contain 3 elements and set B contain 2 elements, and we have the cross product. So cross product is nothing but the ordered pair where first element needs to belong from the first set and the second element needs to belong from the second set. So if you haven't watched the video where I have discussed about the cross product, you can also watch this video from my playlist. So before finding the relation, first we need to find the cross product. So as you all know, the relation is nothing but this subset of cross product, and this cross product is also a relation which contain all the elements. So this cross product is also known as universal relation. So the relation which contain all the elements of cross product is known as universal relation. So A cross B is equal to U equals to universal set, or sorry, universal relation. So the relation which contain all the elements of cross product is known as universal relations. And suppose we want to find the complement of relation, then we need to minus universal set and need to minus that relation. So for example, we have the relation R. So relation is nothing but the subset of A cross B, or a cross product. So this is a relation R, and if we want to find the relation complement of relation, which is usually denote using A dash. So if you want to find the complement of relation, then we need to minus universal set, then we need to minus that relation. So U minus R is the complement of that particular relation. So this whole set is known as universal set, and if you want to find the complement of this relation R, so we need to minus R from universal set. So these are the complement of relation. So we need to minus 1A because 1A is here. So we don't need to include this 1A because 1A is already in a relation. So we don't need to include in R complement. So 1B. So we can include 1B because 1B is not in this relation. So we can't use 1B, so 2A. We can't use this 2A in the inverse of relation, so we need to minus this 2A, and we can include this 2B in our inverse of relations. And we can't include this 3A because 3A is already here in this relation, so we don't need to include in R. Sorry, R dash, that is complement, and we need to include this 3B. So this is nothing but the inverse, sorry, complement of the relation R. So the complement of a relation will contain all the pairs. All the pairs do not belong to a relation but belong to the cross product. So the complement of a relations contain all those elements which are not in relation but in universal set or cross product. So if you want to find the complement of particular relation, then we need to subtract that relation from universal set. So universal set is nothing but it is the cross product. This is how we can find the complement of a relations. So now we are going to see the inverse of relations. So for example, we have same two sets A and B, and we have this cross product. And as you all know, relation is nothing but the subset of that cross product. So we have relation R which contain these elements. So suppose we want to find the inverse of that relations R, we just need to swap the element. So this is how we can represent the inverse of relation. Here A1, we just swap the order of that particular element. So we can put this A as the first element and 1 as the second element. Similarly, we put this, sorry, here I did a mistake. Here I need to put A as the first element and 2 as the second element. And here 3, sorry, here I make another mistake. So this is not the inverse of relation. So we can find the inverse of relations like this. So I'm going to give you the example where we're going to find this. These are the mistake I have made here. So this is okay. So this is okay. So we need to find the another relation. So 2a. So we can find the inverse of relation as a and 2. So this is the inverse of relations, and another relation would be, what will be, a comma 3 would be this two relation is the inverse of relation. A1 is okay because we need to swap this element first and 1 as the second element. So 2 is the first element and 3 is the second element, and 3 is the first element, and sorry, A is the first element and 3 is the second element. So this is how we can find the inverse of relation. So these two are the typing mistake that I have made while preparing the videos. So this is the relation A1, A1, A2, A3, because we just swap the element. So this is how we can find the inverse of relation. So in our next video, we are going to learn other types of relations. So first we are going to we are going to see the reflexive relation, then we are going to see the irreflexive relation. So these are the two types of relations come under the same families. Then we are going to learn symmetric, antisymmetric, and asymmetric. So this is the another family of relations. So after that we are going to learn the transitive relation. So transitive relation, after learning this 6 type of basic relations, then we are going to see the two high order relations, that is equivalence relations and partial order relations. So using these basic type of relations, we can derive the equivalence relations and partial order relation. So this is all for today's video. We are going to see the types of relations more in detail from our next video, where we are going to learn this two basic type of relation, that is reflexive and irreflexive relations. So thank you for watching. See you in next video. Thank you.